All right, so these are your notes for multivariable linear systems and back substitution. With these multivariable linear systems, you're going to have three equations, and you're going to have variables of x, y, and z, or a, b, and c. Instead of giving your answer as an ordered pair, you're going to give your answer as an ordered triple in the form of x, comma, y, comma, z. And again, these are in parentheses. The way that you're going to see these equations is similar to the second one there, where you have that z is equal to a number, you have y and z in one equation, and then you have another equation that's x, y, and z. So if we look at the first example, you are solving x minus 2y plus 3z is equal to 9, y plus 4z is equal to 7, and z is equal to 2. So the easiest thing to do here is to go from the bottom part, plug it into the one above it, solve for y. Then once you get y and z, plug it into the top equation, and then solve it that way. So if we use the bottom, that z is equal to 2 in y plus 4z is equal to 7, that's going to give us y plus 4 times 2 is equal to 7. The 4 times 2 is 8, so that's y plus 8 is equal to 7. We move that 8 over by subtracting it from both sides, and we get that y is negative 1. So now you have that z is equal to 2, y is equal to negative 1. You have to find for x. So we're going to use the top equation, the x minus 2y plus 3z is equal to 9, and solve for x. So this is going to give us x minus 2 times y, which is negative 1, plus 3 times z, which is 2, is equal to 9. The negative 2 times negative 1 is positive 2, so that's x plus 2. The 3 plus 2 is 6, is equal to 9. Your 6 plus 2 is 8, so x plus 8 is equal to 9. We move the 8 over by subtracting it from both sides, and we have that x is 1. So now that we have x, y, and z, we're going to put it in the form of x, comma, y, comma, z, comma. So that's going to give us 1, comma, negative 1, comma, 2. If we look at our next example, it tells us, is the given ordered triple a solution? Show all work. If it is a solution, you are going to plug it into every single one of those equations and get a true statement for all three of them. So we are given for number 1, the ordered pairs of 1, 0, 2. Sorry, the ordered triple of 1, 0, 2. So in this case, your x is 1, y is 0, z is 2. If we use the top equation, your x minus 3y plus z is equal to 3, and we plug in our values. We're going to get 1 minus 3 times 0 plus 2 is equal to 3. The 3 times 0 is 0, so that cancels out, and 1 plus 2 is equal to 3. So 3 is equal to 3. That one works. That's only the first one, though. You got to try the second and the third as well. So the second one, you have 2x plus y minus 5z is equal to negative 8. So this is going to give us 2 times 1 plus 0 minus 5 times 2 is equal to negative 8. The 2 times 1 is 2 plus 0 minus 5 times 2 is minus 10. So 2 plus 0 is just 2, minus 10 gives us negative 8. Negative 8 is equal to negative 8. This one is a true statement as well, so now just try the last. For the last, you have x minus y plus 3z is equal to 7. Again, we're going to use x as 1, y as 0, and z is equal to 2. So this is going to give us 1 minus 0 plus 3 times 2 is equal to 7. The 1 minus 0 is just 1. The 3 times 2 is 6. 1 plus 6 is 7. 7 is equal to 7. That's a true statement as well. So all three of these are true statements. The order triple of 1, 0, and 2 is a solution. For number 2, it gives you the order triple of -3, 1, and 6. So we have the first equation, that's 4x plus 8y plus z is equal to 2. Then x plus 7y minus 3z is equal to -14. And 2x minus 3y plus 2z is equal to 3. So we're going to start with the first one. So we're told that x is -3, y is 1, z is 6. So starting with the 4x plus 8y plus z is equal to 2. We're going to have 4 times -3 plus 8 times 1 plus 6 is equal to 2. 4 times -3 is -12. 8 times 1 is 8. And then we have that 6. So that -12 plus 8 is -4. -4 plus 6 is 2. So 2 is equal to 2. That one's a true statement. Try your next one. You have x plus 7y minus 3z is equal to -14. So that's going to give us -3 plus 7 times 1 minus 3 times 6 is equal to -14. -3 is going to stay -3. 7 times 1 is 7. The -3 times 6 is -18. Your -3 plus 7 is 4. 4 minus 18 is -14. Once again, you have a true statement. So move on to your last equation. Your last equation you have is 2x minus 3y plus 2z is equal to 3. So if we plug in our values, your x is -3. That's 2 times -3 minus 3 times y, which is 1, plus 2 times z, which is 6, is equal to 3. So from here, the 2 times -3 is -6. The -3 times 1 is -3. The 2 times 6 is 12. -6 minus 3 is -9. Plus 12 gives us 3. So once again, you have a true statement. So because all 3 of these are true, the order triple of -3, 1, 6 is a solution. For number 3, you have -4, -3, 4. So your x is -4, y is -3, and z is +4. We're going to start with the first equation. You have x minus y plus z is equal to 2. That's going to give you -4 minus -3 plus 4 is equal to 2. Your -4 cancels out with your +4. Your double negatives turn into a positive, so that's 3 is equal to 2. This is not a true statement. So because that we start with a false statement for that one, the order triple of -4, -3, 4 is not a solution. So it doesn't matter if any of the rest of them are true, because that one is false, it is not a solution. For the next part, you are solving using back substitution. You're going to write your answer as an order triple here. So we're going to take the last part, plug it into the middle part, then plug it in to the first part. So for number 4, you have 2x minus y plus 5z is equal to 24. Y plus 2z is equal to 6, and z is equal to 8. Automatically, z is solved for you. So take that 8, plug it in to the equation on top, and solve for y. This is going to give you y plus 2 times 8 is equal to 6. Your 2 times 8 is 16, so y plus 16 is equal to 6. Move your 16 over, subtract it from both sides, and you get that y is -10. So you have what z is, you have what y is. plug both of those in to the top equation and solve for x. So this is going to give you 2 times x minus y, which is negative 10, plus 5 times z, which is 8, is equal to 24. Your double negatives turn into positives, so that's going to become 2x plus 10 plus 5 times 8 is 40. It's equal to 24. Your 10 plus 40 is 50, so 2x plus 50 is equal to 24. You're going to subtract the 50 from each side. So you get 2x is equal to negative 26. Divide each side by the 2, and you have that x is negative 13. So if we're writing the order triple as x comma y comma z, this is going to give us negative 13 comma negative 10, comma 8. And then if you need to check your work, which if I were you, I would do, you can just plug all three of these x, y, z's into the three equations that are given to you, and you should get true statements for all three. Now, if we look at number 5, you have 7x plus 2y plus 2z is equal to 21. Negative 2y plus 3z is equal to 1, and 4z is equal to 12. Neither or none of these three equations are actually solved for a specific variable. However, if you take that bottom one, the 4z is equal to 12, you can solve for z by just dividing each side by the 4. So you would get that z is 3. Now that you have for z, plug it into the middle one and solve for y. So that's going to give you negative 2y plus 3 times z, which is 3, is equal to 1. The 3 times 3 is 9, so that's negative 2y plus 9 is equal to 1. Move your 9 over, subtract it from both sides. You get negative 2y is equal to negative 8. Divide each side by the negative 2. And you have that y is 4. You now have z and y. So now solve for x. That's going to give you 7 times x plus 2 times 4 plus 2 times 3 is equal to 21. 7 times x, you got to leave it 7x. The 2 times 4 is 8. The 2 times 3 is 6. This is going to give you 7x plus 14 is equal to 21. Subtract your 14 over. You have 7x is equal to 7. Divide each side by the 7, and you get that x is 1. So again, you're putting this in the order triple as x, comma, y, comma, z. So that's going to give you the answer of 1, comma, 4, comma, 3. For your last one, you have x minus 2y plus z is equal to 4, y plus 6z is equal to negative 1, and negative z is equal to negative 2. First thing we're going to do, solve that bottom one. So negative z is equal to negative 2. Divide over that negative, and you get that z is positive 2. Solve for y next. You have y plus 6 times z, which is 2, is equal to negative 1. 6 times 2 is 12, so y plus 12 is equal to negative 1. Move your 12 over. That gives you y is equal to negative 13. Then find for x. X minus 2 times negative 13 plus 2 is equal to 4. The 2 times negative 13, or the negative 2 times negative 13, is 26. So x plus 26 plus 2 is equal to 4. Add your 26 and your 2. That's 28. X plus 28 is equal to 4. Subtract the 28 over, and you have that x is negative 24. So again, if we're plugging this into the order of x, comma, y, comma, z, that's going to give you negative 24, comma, negative 13, comma, 2.